I'm Nina Lopatina. I'm a staff developer relations engineer at Unstructured. I've been here for close to a year now, and previously I've worked across natural language processing and language modeling at startups and venture capital. And I'm joined today by Antonio.
Hi, everyone. I am Antonio Jimeno Yepes. I joined Unstructured a bit later than it started back in 2022. And I'm working on in the R&D team on developing models and evaluating models for document intelligence. And prior to Unstructured, I have a track record of natural language processing and document understanding work. Yeah, back to you, Nina.
Thanks for joining today, Antonio. Antonio will shed light on some of our implementation on contextual chunking, and he'll be available to answer more in-depth questions about our chunking as well. And so for our agenda today, we're going to cover what unstructured is, whether RAG still makes sense in the days of long context. We'll go over how chunking works within unstructured and how we've implemented contextual chunking specifically, and then we'll do a live demo of that contextual chunking in the platform. A little bit of housekeeping before we get started. So if you have something that you want to share in the chat, like where you're joining from, that goes in the chat. There's a separate box for Q&A, and if you would like to ask any questions, you can put those there, and then we'll answer those live. Usually that starts about halfway through the session. And then if you've pre-submitted a question, you can also share your question in the Q&A box because we'll answer those before we get to any pre-submitted questions. We will send a recording to your email after we wrap up. And afterward, if you want to schedule a one-on-one chat to learn more, we'll share information on how to set up a guided proof of concept. And so Unstructured is a Series B startup. We started as an open source offering, and since then are offering an API and UI platform offering. And we've been used across a number of organizations and have a lot of downloads between all of our different offerings. And so what we are all trying to solve is this problem of this rat's nest that you can get if you're trying to build ETL for Gen AI on your own. The first version of our open source and the first version of our product focused just on file transformation, which can require a lot of different packages and then a lot of custom code for your connectors, chunking, embedding, and you end up with just a lot of libraries and a lot of maintenance burden is what a lot of us had discovered before starting and joining Unstructured. And so what we've created is enterprise Gen AI ETL, and that fits neatly between your systems of record and then your graph and vector database to which your RAG system will connect to via your LLM and your observability and retrieval layers. And we're doing this with this conveyor belt of different steps that we're processing the files through between extraction and loading. So for partitioning, chunking, enriching, and embedding, we can call third-party providers, which we're adding more and more of already. For example, we can use our in-house OCR to partition a file and then send it to Anthropic for contextual chunking, and then further enrich with your provider of your choice, and so on until the JSON is completed and loaded to your downstream vector database. Before we start, I know you're all interested in RAG because you joined this webinar, but I think it's always important to reevaluate whether RAG is still useful as potential new methods come out for things like information extraction. And so we wrote a blog recently on an information extraction project that we took on my team. We were looking at SEC S1 filings And we didn't want to assume that RAG, and in this case, agentic RAG, since, we're kind of always evolving our RAG approaches, if that was still going to be more effective than, let's say, throwing the whole document into Gemini 2.0. And so we, for example, we looked at the amount of the data that was extracted. So for each field, some of the ones marked with an asterisk are ones where we know that 100% of the filings should contain that information. The other ones, we're just not sure if the information is missing because it wasn't in the filing or because it wasn't extracted. And so what we found was that overall, we still found that agentic RAG was more performant than long context, especially for something like extracting the sales model and average deal size. We were able to extract a lot more information with this approach. And I'll note that this was before we had implemented contextual chunking. So I think that actually that extraction would go way up. We just haven't had a chance to measure it. And then there's a notable exception of categories for the company in the filing. And so that actually was extracted more performantly with long context. So I think that was an important distinction in that with these really complicated documents, RAG will overall be more performant, but if you have a question that spans the full document itself, then perhaps, for that kind of task, long context may be better for your needs. We also compared pricing for answering each question. And we found that the long context was a lot more expensive by cost and the number of tokens used. Note that this doesn't factor in the initial setup, so it's kind of something that may have an initial cost for RAG, and then this is the price for, let's say, extracting 5 different questions. So the cost increases with how much information you're extracting. And we did find that agentic RAG was slower. We didn't really optimize our approach for speed, but in general, agentic approaches will be slower overall. And so, so this was a good confirmation just like a month ago or so that yes, RAG is still important. And so what can we do to improve our RAG? So I'll talk about how we've set up our chunking overall. And that kind of we need to take a few steps back and kind of start from the partitioning step to know what it is that we're feeding into the chunking step. And so we are atomizing files into elements. So we're detecting if there's a title, a subheading, an image, a table, and then we're extracting those as individual elements so that your document is partitioned or split up into different component elements. And so, for example, different elements could be something like text or a photo or a table, and we would send those all automatically to a different processing pipeline. For example, using OCR for text, since you don't need to over-engineer and throw a VLM at simple text, but then you could use a LLM to generate a summary of an image, and then all of that gets output to your JSON before the chunking step. We're also extracting a lot of metadata. Things like when the file was last modified, the file name, the page number, a lot of things that you can use in your metadata filtering in your RAG system that can be very helpful. For example, filtering by when a file was modified to make sure that you're getting recent information and things like that. We have 30 plus different fields of metadata depending on the file type and source. And so before we do the chunking, we're combining the elements and the metadata all into JSON that goes into the chunking node. We have a number of different parameters that users can set. So for example, you can set the chunk size with a soft limit, which is new after n characters, and a hard limit, max characters. That's a very, that kind of is a parameter that is very intrinsic to chunking, the size of the chunk. You can set the overlap. So you can set the overlap size. And then we also allow for including original elements, and those will be serialized, but then that can help you understand which different elements were in the document or in the chunk. And then we can also chunk by the element type. And then we'll note that table elements are always treated as standalone chunks. And so in a basic strategy, which is just kind of your very basic chunking, you can see how some of these parameters play out. So let's say this is your chunk. It has some overlap in it. It has a number of elements, and that would fall below the soft limit in some cases and definitely before the hard limit. So for example, in scenario 1, you have an element that's too long, and it's going to get split at the hard limit, and this last part will end up in the second chunk. In scenario 2, you have these two elements, and the first one will be its own chunk, and the second one will go in a new chunk. And this third scenario, you're now combining a number of elements to form a chunk. And then the overlap all setting will have overlap between your elements, and if you don't set overlap, they will all be unique content. And then in our chunk by title strategy, you can set it to start a new chunk with a title so that if you have information that pertains to that title, it will better be combined. And then and that can play out differently depending on the other settings that you're putting in. For example, on the examples on the left side, your overall number of text between your titles is pretty long. So you may not have a title starting every chunk versus on the other side, if you've set on the right side, if you've set a really high limit, then you would have a new chunk only when you have a new title. So it kind of depends on your document how you can set the boundaries. We provide a lot of different parameters, so that means that there's ways that you can go wrong. And so, for example, if you have a really low new after n characters and then a pretty high combined text under n characters, so your soft limit is the new after n characters, and combined text is a parameter that combines text under a certain size, and then you have a really high hard limit that you'll never reach because you're combining text under a certain number of characters. You'll be trying to do chunk by title, but you'll end up with titles in random places in your chunks. Also, similarly, if you've set your combined text under n characters, to your max characters, that also will be will give you kind of a weird chunking setup. You can skip the new after n characters and just have a combined parameter and a max. And this is kind of what we recommend as best practices for these chunking overall. So, for example, 256 would be characters that you want combined so that you don't have super short chunks. And then a soft limit of like maybe 1024 and a hard limit of 4096. So maybe if you have a really long element, it will still be included in some chunks. These are just some suggestions that we've recently found in experimentation, but this all kind of varies based on your own data and use case. And so these are kind of our overall recommendations for our original chunking strategies. And then we have a suggestion for how you can experiment with these, which would be to set up a workflow without chunking and embedding, write those results to blob storage. So you could, for example, use a VLM to partition all your data. And then you can use the fast strategy in the next round. And then you can just do chunking and embedding and try those different options for yourself. And then one of our newest offerings then is contextual chunking. So this is kind of an overlay. You can use it in conjunction with everything else that I just talked about. So you would want to, think about all of those different things like the chunking strategy and your character length parameters in addition to just toggling on contextual chunking, but it's as easy as a toggle. I'll show it in my demo after we talk about how we implemented it. And so this was inspired by earlier work by Anthropic. So they had come up with a contextual retrieval preprocessing approach where you take all of your chunks and then you run a prompt for every chunk along with the full document, so that and this is their example, this is the prompt that they used. And so now you're going to prepend additional information, additional context before what would have been your original chunk. And then that all gets embedded so that what they found was that they reduced the top 20 chunk retrieval failure rate by 35%. And soon we'll talk about how we iterated on that prompt and were able to drop retrieval failure even further. But for example, without contextual chunking, your chunk would be the company's revenue grew by 3% over the previous quarter. That's really not that helpful in retrieval. You don't know what the company is when you are situated in time. And so you're really not going to be able to answer any questions based on that chunk. But then the contextualist chunk adds an additional piece. It says, this chunk is from an SEC filing on Acme Corp's performance in Q2 2023. The previous quarter's revenue was $314 million. And then it has the original text. The company's revenue grew by 3% over the previous quarter. Now, this is going to be a really useful chunk and much more useful in your RAG setup. And so we did our own experiments with this, and we've used longer chunk sizes. And even if you're using a longer chunk size, you're still not likely to have all the information that you need to situate that chunk within its context, just in the chunk itself. And so here, even for a long chunk, the contextual chunking is really helpful. It tells you that it's a Form 10K, who it was filed by, when the fiscal year ended, and has information about what the original text document that the chunk came from contains. And then we improved on the prompt with just some very minor changes, and we're able to find that compared to in our experiment over some hundreds of documents. My colleague Maria wrote a blog about this that you can read for more information. Compared to a 7% failure rate with no context and about 4% with Anthropic's prompt, we were able to bring that retrieval failure rate down to 1% with the contextual chunking that we implemented. I'll turn it back over to Antonio to talk a little bit more about our own implementation and some of the challenges that we faced in bringing this into a production scale system.
Thanks, Nina. So contextual chunking relies on providing the chunk to an LLM, and in addition to the chunk, the whole document. So the chunk can be contextualized properly. There are a few challenges. One is that this becomes a very big prompt, and providers like Anthropic already provide mechanisms to cache some of the information in the prompt. As soon as the prompt is longer than 1024 tokens, the prompt get cached, so the following calls are faster and cheaper. So even though this requires processing a large number of tokens, because it needs to look at the whole document in addition to the current chunk, there is some speed up and benefits that are coming with existing providers. The second is that obviously we need to process a large number of chunks with this methodology. So we have parallelized the processing, which allow us to process documents with over 1,000 pages in a few minutes instead of a large amount of time. And in the case of very, very long documents, sometimes it doesn't make sense to send the whole document to contextualize a given chunk. So we'll provide as well mechanisms to send partitions of the larger document in which the chunk is included, instead of having to send the whole document for processing every single chunk. So this makes sense if you have documents with a few thousands of pages, where probably it will be difficult to contextualize the chunks within that setting. So overall, there were a few challenges, and it was an interesting work. But we have an option now that is quite interesting and doesn't add much more time for the processing of documents. So you get nice set of chunks, as Nina showed, that provide a very good performance in retrieval. And it has provided a nice set of new capabilities to our system. Back to you, Nina.
Yeah, that's great. Yeah, it was a really great initial setup by Anthropic, and it took quite a bit of work to get it to cover real world cases and edge cases, and really the kinds of things that you would run into running pre-processing on documents at really large scale, which is what we have optimized for. And so now I'll go into the demo of how all of this works. So this is Unstructured platform, and we also have this is our UI, and so we also have an API. So pretty much everything that I'm showing you, you could also implement programmatically. And so we have a lot of information to get started on the start page. And then the way you would start using the UI is you would go to the connectors. Oh, got signed back out. You would go to the connectors, and for example, you would create a new connector. We have a number of different sources that we support, and then a number of different destinations, and we're adding more from our open source very frequently. And for example, for a source, you would just, let's say, put in your bucket. This is from the S1 project I described earlier, and you would put in your AWS key and your secret key, and that's all you need, assuming your permissions are set correctly, to get access to your data. And similarly, for the destinations, you would point to where the data is going, and then the credentials to be able to write there. And then setting up a workflow is super easy. You can build it for me, and then let's say this is for a chunking demo. So we'll take a source and a destination. We recommend using our auto strategy. And so that's going to automatically select which partitioner to use, whether that's VLM or something like fast or high res. And this has a lot of different default settings. And then if you don't select reprocess all, there's a really neat feature that if you want to repeat your run, let's say every 15 minutes, it will pick up only new files and then add those to your destination, or it will pick up files that have changed, and then it will also deduplicate on the destination side. Just a really neat feature that we offer. And so I'll go to a workflow I had set up earlier for contextual chunking. So I'll just click run on that again, and I'll show you how once you've set up the basics of a workflow, you can just click on that workflow, and then you can go in and you can make some edits. You can add more sources if you want. You can change your partitioner. Let's say you want you want to use VLM specifically for these files because they're really tricky, and you want to select which VLM model you're using. In the example I'll be showing, I just have a US Constitution in an S3 bucket. And so for that file, I know it'll just use the fast strategy because it's a simple document and I don't need to think about it. So I can set this workflow to kind of be generic to, thousands or more files in a bucket. You can add something like image description or table description. You could add other enrichments like name entity recognition. And then here is where we set all of the chunking features. So I really like using chunk by title because I feel like it preserves the structure of the document better. Here I've toggled on contextual chunking. And then I've used these settings that I described earlier, the recommended settings that I shared earlier with the overlap. And then I stuck with the default embeddings, and but there's a lot of different ones that we offer. And then I'm writing this all to AstraDB. And so I'm gonna go look at my jobs now, and that finished running already. The chunking contextual workflow. So that took 1 minute and 23 seconds. And I ran this yesterday. I just have the contextual chunking toggled on and off for 2 workflows to show the difference. And so the difference is just a few seconds. And I'll note that it's always less impressive to show a demo with 1 file with unstructured because we have a lot of concurrency and parallelization. So, a bucket with 1,000 files would take maybe 30 minutes rather than taking 1,000 times longer than this 1 file run did. But it's easier to show what the contents look like. And then after you run the job, you can look at the progress that the file went through and all the different steps and check, that everything looks right. And so it was written to my Astro database. And so this is my examples without the contextual chunking. So it's just regular chunks of content. And then if you look at the ones I wrote with the chunking, you can see that each of them has this prefix. And so in this chunk, you'll see it tells you the chunk appears in the amendment section of the US Constitution, specifically which parts it contains, and otherwise situates it within the document and tells you what it pertains to. And then it has the original chunk after that. And this is all that got embedded all together and written to the vector database. And so that's how our implementation of contextual chunking looks and runs. And so we'll switch to the Q&A now. And then I've shared some links here to get started to either contact our team for a no-cost guided proof of concept, or you could start using the UI or API and use the contextual chunking today if you go to this developers link. Yeah, now I'll pull up the Q&A. And we'll start answering this. Okay, so can we get first question here is from Tina. And by the way, I think I saw some folks shared some questions in the chat. We only look at the Q&A when we're going through the questions. So
yeah, so I've been answering some of them, so there are still some of them that are not being answered, but I think some of them you're better qualified to do so.
Oh, great, thanks. Yeah, so then question from Tina, can we get a bit more information or example about the categories case used where RAG didn't extract all the info expected? Yeah, so that was in our S1 information extraction project. And so here basically it didn't extract all the information. For example, the output would just be like, there's no context with that information. So it didn't happen. It happened, let's say like 30% of the time, and otherwise it would extract categories. But, that might happen if, for example, you're not getting categories in the same chunk. Maybe your chunks are smaller or something, and you're not going to get the categories in the chunk. And we also did find that in other cases, the categories were extracted, but they weren't as comprehensive because maybe the top retrieved chunks didn't include all the categories that you might find across the full document. So we found that both the retrieval quality was better here for a long context and also the quality of the responses. And then let's see. Question from Cameron, is chunking parameters for your product only, or can that be used, let's say, with llama type setup? So our chunking setup is, I think, is a little bit unique. So for example, I'm not familiar of other providers that have this chunk by title offering, although, we've had that probably for well over the year that I've been here. So maybe some others have maybe something more similar. And then similarly, I'm not sure about the chunk options, but something like chunk by title really requires the initial steps that I described for partitioning. And then also we are the only ETL provider that I'm aware of that offers contextual chunking out of the box like this. And then question from Bill, what did graph refer to in graph and vector? So we support graph and vector databases. And so to set up your connectors on the destination, you can use for example, Neo4j or DataStax AstraDB. They both support the creation of graph vector stores. So we also support building those graphs out of the box through Unstructured. Although the edges and nodes are a little bit less fully customizable, and that's something that we're working on. But we support a number of different destinations. Question from Theodore, does Unstructured support GraphRag-based approaches? Yes, so we've had some previous webinars with AstraDB where we talk about how to set up GraphRag with Astra, and we have a notebook there showing how to use it. If you just search for GraphRag Unstructured Astra. And then we also have an example notebook on setting this up with Neo4j. I'm not sure if that's up on our resources list yet. And these are both evolving, where we have something coming out probably over the next month or so with AstraDB, where you can set up GraphRag with any edges or nodes that you can find in our metadata. For example, you can set them up with named entities and things like that. Question from G, any estimate on expense and latency for contextual chunking? So yeah, the latency, as I kind of showed in in this run here, is it for processing the exact same file is just a few seconds difference. So it's a small percentage of the total runtime. And again, all of this scales with more documents. So I imagine the difference would be smaller with more documents as well. And expense-wise, I don't believe that there's an expense to the user in running this on their end. Because I think we're charging by page. And so, yeah, that's just something that we've really optimized the cost for, so that we can just offer it out of the box to users. As Antonio mentioned, with the caching and things like that. So we've really brought the expense down so that the user doesn't have to see that expense. But if you were to implement it yourself, I'm not sure.
Yeah, the caching helps with both the pricing and the speed. So definitely caching will make things cheaper, because the cost of processing after having processed the first chunks will reduce quite a lot.
Yeah. Question from AK, what are the most common applications that users are using this chunking and embedding for? I'm not sure. It's pretty new, so I am not aware of any users using it, but I myself have found it, like, it's something that I would use for the example that I shared earlier on extracting information from SEC S1 filings, like especially anything where you want to reference the file that it came from, because that's really critical to the information. Like, I'm really excited now that we have contextual chunking to run through this again and see and then share in another blog post what the difference is. So for I would say for like reports, financial documents, things like that, for sure, this would be really useful. Question from Dhruv, is the team thinking of adding an option of setting up contextual chunking for the open source package? Is it possible to give an idea of how we can implement it? So no, for the open source package, that's just going to be a very basic partition. And that's something that is not the focus of our current development, since we've really been focused on making unstructured enterprise ready. And so none of our new features are coming to the open source. Those are all for enterprise. And then to implement it, if you want to implement it yourself, you can just check the blog I linked from Anthropic. That was what we started from. But I think, as Antonio shared, there's a lot of steps and a lot of things to do to really optimize it. Question from Tim: how do you handle access restrictions on chunks? For example, assuming chunks come from private user data sources, can you configure a UUID restriction or pass through row level security? That's a great question. So we are not ourselves handling access, for example. We're just doing the partitioning and processing, but we are able to extract security metadata. And so if a file has security metadata, like users that are allowed to access it, then each chunk will have that information as well. So then you can configure your RAG setup to use that information as well. And then we also have role-based access control for unstructured overall in the enterprise offering. Question from Bart: I work with document stores that get PDFs from API, so it's a different source. Would love to get Flowise or a webhook as a source connector, or make the integration in Flowise include contextual chunking and stuff. That's a great question too. So our connector repository is open source, and so and so we have other sources and destinations coming in all the time. If someone from, if you want to ping someone at Flowise and suggest that they make a connector with us, we're always happy to partner and support folks, and they can see how the other ones have been built, because that's all open source. Or you could build it yourself if you'd like. And yeah, we also like to note requests that come in, so that as we're building more and more connectors, we can add Flowise to the list. Question from Tom: you don't use knowledge graphs with RAG for improving answer accuracy. So sometimes for some projects we do. We're still really fleshing out our knowledge graph setup. So I think that's something that we'll have more content around in the next few months. Because right now, our current implementations, I think, are just starting to have named entities and things. And I actually think that for this specific project, for extraction completeness, I don't think the knowledge graph would help that much. I actually think what would be most useful would be the contextual chunking. And for example, something we used for this was, this project was metadata filtering, so that if there was, if we're trying to answer questions about a specific company, we filter only to documents from that company, so that really helps. But then it would be helpful to know like which section something came from. So if there's like a section about categories and that's indicated, that would help, for example, boost that responsiveness. Question from AK: I am new to Unstructured. What are some of the other core capabilities besides sophisticated chunking that you do? So some of the other things that we have built in to our workflows, and especially our connectors, are things like incremental syncing. And so this lets you update based on new files being added, so that you don't have to rerun the whole workflow. For example, it's easy to process all your files. It's fairly easy to just go and process all your files, but then keeping things up to date is really critical for RAG. For example, bringing that, keeping that up to date would mean that you're getting like up to date responses from the information in your destination connector. And so if you are, if you're updating your files, you really want to make sure that you're getting answers that are deduplicated as well. You don't want to have two versions of the same file. And so that deduplication will help preserve like the quality of your database. Question from Etienne, 90 seconds is a really long time, and would disqualify the use of agentic RAG for any real-time application. Can you give some context to this latency figure? Yeah, so that was just having the agentic setup ask multiple, so the agent will basically decompose the question and then have that be a set of tasks, and then it would answer and come back with a complete answer. And so that was something that was not like something that we that's not something that we offer in our product. It's not something that we've productionized. It was just a prototype that we had put together to do an information extraction project. So I would say that's definitely something that if that's what you wanted to implement for your RAG, there's definitely a lot of things you could do to speed that up, like have the questions answered concurrently, and things like that, because they're independent, and optimize the runtime of your LLM and things like that. So I think that's the main driver of that latency. Question from Andreas: what is your experience or best practice when it comes to retrieving information that is spread across multiple different files and file types, e.g. a spare part mentioned in a manual file that is described in detail in an Excel file and an image in a PDF? Interesting question. Antonio, do you have any suggestions for this?
Yes, second, I was answering some questions in the Q&A in the meantime, so let me have a closer look. Yeah, so in principle, we have different strategies that can work with Excel files and PDFs and many types of documents. So in principle, as soon as the partition strategy can deal with all the different types of documents that you need to process, in principle, what we have provided here should be applicable. So you have a set of elements coming out of each file that will be indexed in the RAG system, and then should be recovered and processed for generation in the later part. So it's identifying the types of files that you have, and then understanding what is the best partitioning strategy that will give you the best set of chunks, and obviously identify what chunking strategy works best for the different sets of files that you have. So Nina presented a set of parameters that have worked well in most of our use cases. So it will be a good idea to start with those and examine what would be relevant in your case. But I would say that we can manage complex documents, and being able to recover information from RAG once the documents are processed. Yeah, thank you.
Yeah, thanks. Question from Om. What approach to try when I have legal documents which have similar format and I want the user to query, summarize the cases, or get to know about who were involved in the case, which needs to be answered from each document. So that's a great use case for legal documents, for contextual chunking, because that's going to potentially add that context about who was in the case, or the case title or something like that.
Yes, that's right. There was another question that somehow related, in which documents might include information about different states in the US. So a given chunk might not contain the information about the state it's referring to. So contextual chunking here helps again to contextualize and add relevant information that is bound to this chunk. So those two great cases for what Nina has presented today.
Yeah, thanks. Question from Raja: by how much percentage did the chunking cost increase by, since we are additionally using LLM to contextualize the chunk? So that's a cost that we have optimized so much that we don't pass it to our customers. So that's not something that you would need to worry about. Question from AK, do you also support BigQuery? I'm not sure about that.
I'm
And
not
I
sure
don't,
either.
yeah, I don't think we have it in our UI. But we have even more connectors in our open source that you can look at, and then you could use the API along with those. And another question about use cases, asking what are common use cases that Unstructured is used for? Oh, so we're used a lot for RAG, for pre-processing data for RAG, for graph RAG, for loading data to unstructured data to any database. So really, ETL for Gen AI is our main value proposition. Enterprise ETL for Gen AI. Question from Tanmai. How do you ensure that RAG remains reliable when dealing with highly dynamic or rapidly changing information like real-time news or stock market data? That's a really great question. So something like news or stock market data. So that's a little different than like the incremental syncing I mentioned earlier, where if you're updating your own files, because this is new information that's coming in a different file. So for that, I would recommend leveraging the metadata that we're pulling out. And so in that metadata, you're going to have things like when it was last modified or when the file was created. And so you could set up your RAG system so that, like, let's say you want only information from the last month or something, you can filter so that it doesn't look for things that are older than whatever time you specify, and you may want to experiment with different times. And you could also have like a tiered retrieval system where, like, let's say there's a topic that's not super popular. So if you're limiting it to the last month, if you don't pull up anything, then you can extend that window and look further back. For example, for news, and then for stock market, yeah, I would say definitely the metadata filtering will be your friend there. So question from Mark, if I already have a bunch of metadata associated with my files, can I pass that metadata to Unstructured along with the files so that it gets carried through to each chunk? Yes. So this metadata is something that we're not creating. It's just the metadata that exists along with your file. And so in our documentation, we have a list of those 30 fields and how they vary based on the file type and the connector. So we have, for example, different fields for emails, different fields for other different file types, and then there's some that are connector based. Question from Kamakani. I asked a question about processing HTML files. I believe Unstructured can receive a list of URLs. Does contextual chunking work on these file types, or do they first need to be converted to Markdown? No, so they don't need to be converted. As far as the list of URLs,
Yeah, I'm not sure about that. If we have a source connector that handles with list of URLs, or the URLs need to be, or the HTML files need to be provided already to in source. So this is something we could check.
yeah, I think you would need to provide the HTML files themselves instead of just the URLs. But then what we would do for HTML files is in our workflow, the partition step would be, you can still use auto because it'll figure this out itself, but it would be the fast strategy. And so this is going to process HTML files, and then all the other steps are the same. So we kind of bring all the same files to the same JSON format as part of our processing. Question from Jonathan, how do you recommend scaling document ingestion for large files, 500 pages, while not splitting up context between pages? Antonio, do you have a suggestion there?
In principle, the partitioning part of the processing will take care of running different pages in parallel. But we process pages. The output of the processing will provide information per page. So not sure if the question is referring to linking context between pages, which we are not currently supporting. So in the sense that it will still be efficient to process the documents, but we don't link information across pages for now.
Yeah, I would say this is a great place where the contextual chunking is going to be really great. You could process the chunks that are, large size, like 4,000 or so. That would be about a page. And if you're using the contextual chunking, then that's going to help preserve context more thoroughly throughout the document. But as Antonio mentioned, for really large files, we're not going to pass the full document.
Yes,
So
there will
that's
be a limit, and that will allow better contextualization of the document and will be as well faster and cheaper to do instead of giving the whole 500 pages, which probably don't add much relevant contextual information to a chunk.
Yeah. And I would say for that question, Jonathan, I would suggest reaching out to our enterprise team. So everything that I describe in my webinars is what we offer out of the box to any developer or user. But our enterprise team can help work with you, with our solutions engineers, and then help figure out, custom pieces that you may need in the workflow for something like what you've described with really large files or really anything else that is not covered by our by our basic UI or API. Question from Raja, what if my document is long beyond the context size of the model used for contextualizing? So that's where we're splitting up the document so that you're not going to get the context of the full document. But again, if you reach out to our enterprise team, that's something that they can help you if you need some kind of solution that works around that still has the full document, that's something that they'd be able to help you with.
Yes, it's configurable. So we have a default set of values, and that can be the options for customization.
Yeah, thanks. And then another question from Raja, does contextualizing chunk also take into all images from the document into account to contextualize, or is it only text? That's a great question. So for example, when you do the image summarization, or let's say table description or something, well, that one's not going to go in the chunk, the name entity recognition. But if you're adding these descriptions are going into the chunks as well. So that's why these steps are happening before the chunking step. So that will be included, and you'll also have the base 64 encoding of the image if you want to pull out the image as well in your retrieval. The recordings will be sent to your emails. And oh, interesting. I see that we have a blog for processing HTML by URL from
Yeah, thank you
Kamakani.
for sharing that.
Yeah, thank you. I wasn't aware of that one. But yeah, that's great. And then question from Molly, what is the ultimate output? Is it a chatbot or the contextualized chunks? Yeah, so what I showed here in AstraDB, which I like for this demo because they have a JSON option to display. So this is exactly like everything that's here is what we wrote as output. So we wrote the vectors, the content, we have metadata, so you can do metadata filtering and things like that. So this is all stuff that we took from the file in the S3 bucket and created this full output here. And then we wrote it to your vector database or whatever destination, blob storage or graph database or wherever you're building your application from. And so then that's where, it's up to your own imagination and engineering to create the chatbot or whatever else you need from that vector database. But basically the vector database is completely ready with all of your information that you've loaded into it, so that that's ready to go to answer questions from your chatbot. So at that point, all you need to do is link an LLM and then set up the RAG system. And we have in our documentation, if you go to our website, in our docs, we have a section called example code. And so this is going to be example code that, shows you how to do like how to set up agentic RAG, how to do RAG evaluation, how to do quantitative reasoning with tables, custom metadata extraction. So it has a lot of different options that show you how you could build at least a RAG prototype from the content that you've gotten from Unstructured. Great. We've gotten through all the questions, very much with Antonio's help answering questions in the chat as well.
No worries.
So I'll go to a question from one of the pre-submitted questions that we had. Many documents contain multimodal features, images, charts, tables, in addition to text. How can we capture this information in a RAG system and relate it to the text content? So this is something that the enrichments can help with, and something that you can incorporate into your RAG system will be those descriptions. And then we have a notebook as well, multimodal RAG, enhancing RAG outputs with image results. And that shows you how to extract the base 64 encoding of images or the text as HTML for the tables, so that if you wanted to, let's say, output an image along with your response, you can do that as well using Unstructured. And another question that was pre-submitted, how do you manage temporal information in RAG systems beyond simply waiting by time to mitigate the risk of retrieving outdated data? Yeah, so there's a few things that we offer for that. One is overwriting data that's been updated, or using the metadata filtering by when a file was modified, for example. And question that just came in from Felicia, this will be our last question. Is contextual chunking better than RAG when it comes to avoiding the forgotten middle problem? I'm referring to the phenomenon where the middle of a long document is ignored. Sorry if you already answered this, I joined late. So this is referring to, I guess, the needle in a haystack problem. So contextual chunking, contextual chunking is something that you would use within a RAG system. So I would say it's probably not as helpful for a needle in a haystack specifically, but it will improve your retrieval. So potentially it could give you a better answer, because it's going to have that additional context to enable pulling that, that small one detail chunk that could get lost. For example, there's something like the company's revenue grew by 3% over the previous quarter. Something like contextual chunking can help with that kind of extraction, compared to like using long context, which does suffer from the needle in a haystack problem. So great. Thanks everyone for joining today. We'll share the recording out later, and hope you learned something today. And thanks to Antonio for joining as well.
Thank you, Nina, and thank you, everyone.
Bye, everyone. Thank you.
Bye.